Hi guys, it's Ian here from Crack Maths and welcome to this exam paper walkthrough for the November 2023 foundation paper for AQA Maths. This is the non-calculator paper. If you want a link to it, you can find this on my website. Other than that, I will briefly pause before answering the questions so you can have a go as we work along. Okay, right, let's begin. So the first question here says, write down the value of 2 to the power of 3. So 2 to the power of 3 means 2 times 2 times 2. So 2 times 2 is 4, and then we have 4 times 2, which is going to equal 8. Question 1, B. Work out 3.45 plus 2.07, take away 1.3. If you want to have a go, pause here. Otherwise, I'm going to continue. So here we are. I'm going to write all of these. I'm going to do these two first. So 3.45, and I'm going to write it with the dots lined up, with the decimal places lined up. I'm going to add these with the column method. So we've got 5 add 7 is 12. Carry the 1. 4 add 0 is still 4. Add 1 makes 5. Put the dot there. 3 add 2 is 5. So these two bits make 5.52. And now we've got to take away the 1.3. So I'm going to do 5.52. Take away 1.3. I'm going to add a 0 here just so we've got the same number of digits. Remember, after the decimal place, you can put as many zeros as you like because it doesn't matter. It doesn't actually impact anything. So here we go. We've got 2 take away 0 is 2. 5 take away 3 is 2. And 5 take away 1 is 4. Must remember to include the decimal place. So here we go. The answer is 4.22. Okay, great. Let's have a go at the next one. So here we go. We've got question 2. And this question says, here is a triangle. And it says, measure the length of side X. Give your answer in millimeters. In order to do that, I'm actually going to be using a ruler, but you're not going to be able to see it on the screen, unfortunately. But you're going to have to trust me as I measure it. I'm going to put the line at one end here and do that like this. And what I'm getting here is I'm getting that this line is 6.9 centimeters. So in a way, I can't really, it's a bit of a tricky one. This wasn't a great second question to have, but let's continue anyway. So that was 6.9 centimeters. The angle, again, I'm gonna struggle with this one as well. Anyway, the angle one, I'm gonna have to use this device here. It's a protractor. So I'm gonna put it on my tablet here, but you're not gonna be able to see it, unfortunately. But I will be able to tell you that it is 32 degrees. What I want to do now is let's have a look at actually answering these questions here because they've specified different units. Okay, so here we go. Measure the length of side X. Give your answer in millimeters. So we've done that on the ruler. So it's 6.9 centimeters. To go from centimeters to millimeters, we times by 10. So that would be 69 millimeters. And then measure the size of angle Y. We've got that there. We've measured that as 32 degrees. So remember, to do the angle, you wanted a protractor, and then to do the side, you wanted a ruler. Sorry about the poor execution of that online for you. Question 3 says, write a number in the box which makes the statement correct. So this can be any number that is bigger than 3.7. So I could even have like 100 here. So 100 is greater than 3.7. That is a very true statement. Question 4a. Here is a number line. Which number is A? Right, okay, so we have got 1, 2, 3, 4. So 4 lines, okay, make up 1. So what I'm going to have to do is 4 lines equals 1. Okay, so 2 lines will equal 0.5. So which means that 1 line equals 0.25. So this line here, A, is going to be at 1.25. And we can just check that by writing these things here. So 0, 0.25, 0.5, 0.75, 1. Yeah, so that would be 1.25, 1.5, 1.75, 2. Next bit here, here is another number line. Which number is at B? So again, we've got, how many dashes do we have here? We've got 1, 2, 3, 4, 5. Okay, so we've got 5 and it covers 1,000. So 5 lines equals 1,000. So we need to basically divide this 1,000 by 5. So if you don't know how to do that, we can do it with a bus stop method. So 5s into 1 don't go. 5s into, so carry the 1. 5s into 10 go twice. 0, 0. So here we go. Each one of these things is going to mark an incremental increase of 200. So if I was going, and we're going, the numbers are getting smaller this way. So what we're going to do is this is going to be that'd be minus 2,200. This would be minus 2,400. This would be minus 2,600, minus 2,800, minus 3,000. So this will be minus 3,200. So B will be at minus 3,400. So there we go. Minus 3,400. Okay, great. Right, let's move on to the next question. Here is a shape. Write down the order of rotational symmetry of this shape. Okay, right. So let's actually I will do this using, I've got a rotating tool here. So let me just draw round this shape. I wonder if I can do it with a highlighter. That might be nicer. You'll get tracing paper in your exam, so that can help you out with this. So here we go. I'm going to put a dot here as my counter. So I'm just saying this is where the dot started. Now what I'm going to do is I'm going to go around here, and you can do this with your tracing paper if you want, and I'm going to spin it to see how many times it makes the same shape. So once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, and then 10 times. Okay, so we're back there. So let me just double check that by counting these things. So basically it's every single one of these. So we've got order 1, order 2, order 3, order 4, order 5, order 6, order 7, order 8, order 9, order 10. Okay, so it goes round 10 times. So the order of rotational symmetry is going to be 10. So I'll put a 10 here. Right, question 6. Simplify fully A plus A plus A plus A. So that means we've got 4 A's. So we'd write that 4A, okay, because that means 4 times A. We've got 4 A's there. The next one, we've got factorise 5A plus 10. So factorise means find the factors. So there's numerical factors here, and I can see that both of these numbers can be divided by 5. So I'm going to think about this as being 5 times something. So to get 5A, we need 5 times A. To get 10, we need 5 times 2. So I'll put that here. Part C says, multiply out 4 lots of bracket 10 minus x. So this means we've got 4 lots of the 10, which makes 40. And we've got 4 lots of the negative x, which makes minus 4x. Okay, right. So question 7. Here we go. It says, Ollie and Rachel run a marathon race. Ollie starts the race at 9:15 a.m. and he takes 3 3/4 hours to finish the race. What time did he finish? Okay, right. So 3/4 of an hour, if you should hopefully know that that is going to be 45 minutes. 3 over 4 of an hour, it's 3/4 of 60. And we often use this, it's 45 minutes. But it kind of makes more sense if we just kind of say it out loud. The next bit, 3 hours. So we've got 3 hours and 45 minutes to win this race. Not to win this race, to finish this race. So we're going to do 15, add 45 for the minutes. Okay, I'll do that with the column method. Or you might already know that 15 add 45 makes 60, because that's going to be 5 add 5 is 10. Add a 1 here, carry this. 1 add 4, add 1 again is 6. So here we go, that's 60 minutes there. So 60 minutes is also an hour. So if we're starting at 9:15, if we add on the 45 minutes, that's completed the hour. So 9:15, add 45 minutes. That takes us up to 10 o'clock. And now what we have next is we have to add on the 3 hours. So 10 o'clock, add 3 hours will be 13 o'clock. Okay, and we can call that 13 o'clock in terms of 24-hour clock, or we could call that 1 p.m. I'll just have a quick look of the mark scheme, and the mark scheme is happy with either 13 o'clock or 1 p.m. Okay, so let's have a look at question 7b. It says Rachel has a target of 4 hours and 10 minutes, and she has been running for 186 minutes. To meet her target, how many minutes does she have left to finish the race? Okay, right, so what we're going to have to do here is we're going to have to convert the hours for her target into minutes, and then we can take away the minutes that she's been running from that. So let's have a look. First of all, so we know that 1 hour equals 60 minutes. 2 hours is double that, so that's 120 minutes. 4 hours is double that again, so that's 240 minutes. And then we want 4 hours and 10 minutes. So the 4 hours, add the 10 minutes, equals 250 minutes. So her target time is 250 minutes. She's been running for 186 minutes. So what we need to do is we need to do 250, take away 186, and let's have a look at how that goes. 0 take away 6 we can't do, so let's borrow 1 from here, turn that into a 4, and turn that into a 10. So now it's like 240 and 10, as opposed to 250, but 240 and 10 makes the same thing. So 10 take away 6 is 4. 4 take away 8 we can't do, so we'll borrow 1 from this 2, and we'll put that here. So now we've got 14 take away 8. 14 take away 8 is 6, and then 1 take away 1 is 0. So she has 64 minutes left to finish the race. Right, next question. Okay, here we go for question 8. Shamira uses a tally chart to record the vehicles passing her school. Here is the chart with the tallies. Each 5-bar gate represents 5 vehicles. So let's just tally this up first and see what we're talking about then. So if each one of these is 5, we've got here 5, 10, 15, 20, and then 3 here. So this one's got a frequency of 23. This one has 5, 10, 12. This one's got 5 and 4, which makes 9. And this one is just 4. Okay, so the first part of this question says, Shamira says the number of cars is more than the total of other vehicles because they have 4 5-bar gates and the other vehicles collectively, only have 3 5-bar gates. Is she correct? Okay, well, let's first of all just have a look. She is right that the cars have 4 5-bar gates and the other vehicles only have 3 5-bar gates amongst them. But is she correct? Well, we know that the total number of the cars is 23, and the other vehicles, well, we can see we've got 12 here, 9 here, that makes 21, and then the 4 here makes 25. So actually, she's wrong, because although the cars do have more 5-bar gates, because of these extra bits here, these that you can see, they actually mean that the other vehicles are still more in number than the cars. Okay, so let's tick no. And to say that, we can just say total cars equals 23 and other vehicles equals 25. Okay, right. Let's have a look at question 8. On the grid, draw a bar chart to represent the tally chart. Okay, right. So let's do it. Let's have, I don't know, we can have 2, 1. Will that work if I have bars like that? No, that's too wide. Let's go for 1 wide then. Okay, so we've got cars first at 23 and then buses at 12. So I'll try doing those first. So we're going to have cars here first, and we're going to have to draw these lines up to 23, which is going to be halfway between 24. So there we go. Draw that nice and neat. And then we've got buses next. And what was the buses total? I think it was 12, wasn't it? So then I'm going to draw the bus next. Bus goes up to 12. Then I think we had van. And I believe van is 9. Yeah, here we go. Van is 9. I'll put that next to it. And that's going to be a half square again up here. And then I can't... Was the last one bike? It must be, right? Lorry. Lorry, of course. Lorry, and that goes up to 4. Right, so here we go. Here is our bar chart that they've asked for. And then I'm just going to, before I finish, I'm going to label this bottom axis as vehicles. There we go. So we've got the bottom axis labelled as vehicles, and we've got the side axes labelled as frequency. Okay, right. Let's continue. So here we go. We've got question 9 here. And question 9 says, put the whole numbers 1 to 12 into the boxes to make the calculations correct. You only use each number once. Whew, is that for the whole thing? What does it mean for each one? I think it must... Oh, let's see how this all goes. So we've got 7 here. So we could do for 7, 1 to 12. We could have... Let's use the low ones for 7. 1, add 2 is 3. Add 4 makes 7. We've got to get up to 32. So we're going to need some high ones here. So we're going to have 12... add 11, well that makes 23, and so if I add 9 there, that will get us up to 32. Here we've got 15, so we're going to have, let's use the 3, and then what haven't we used yet? We haven't used 7 yet. Here we go, 3, 7 and 5 will make 15. Okay, 3 add 7 is 10, and then there, and then lastly, what can we do with this one? Well, what haven't we used? So we haven't used 6, we haven't used 8, and we haven't used 10. So does this one work? 6 add 8 is 14, add 10 is 24. Oh, that's good. I I wonder how many solutions there were to this. I don't know. Okay, well, let's have a look at the next question. So here we go, question 10. We've got a regular pentagon that has a perimeter of 100 millimeters. A shape is made by joining a square to a pentagon. Work out the perimeter of the shape. Okay, right, so if it's 5 sides equals 100 millimeters, then one side is 100 divided by 5, which is 20 millimeters. So here we go, we know that this is 20 millimeters. Now, a shape is made by joining a square to the pentagon, so presumably the square has each side of 20. So here we go. Work out the perimeter of the shape. Well, we don't see that 20, so essentially we've just got all of these sides which are 20. So let's count that up. We've got 20, 40, 60, 80, 100, 120, 140. So that's going to be 140 millimeters for the perimeter, because perimeter means the distance around the outside. Let's have a look at question 11. So last week, Eric worked 10 hours and he paid no tax and received £90. This week, Eric works for 15 hours. He assumes he will be paid the same rate and pay no tax. How much does he expect to receive this week? So let's have a look. So 10 hours equals £90. So 1 hour is going to be this divided by 10. So that would be £9. So 15 hours will be this times 15. So times 15. So here we are. This is just classic direct proportion question. So divide 10 times 15. 9 times 15. Well, we know that 9 times 10 is 90. And then we can do 9 times 5 equals 45. So 15 hours will be our 90 plus our 45. Okay, which will be 531. So that 15 hours will be £135. Let's have a look at part B. Part B. Oh, 1 second. Let's write our answer in the right place first and then have a look at part B. So here we go. 11B says, in fact, this week, Eric is paid an extra 50p per hour and pays £8.90 tax. What does this tell you about the amount he receives? Tick one box. It is less than he expected. It is the same as he expected. It is more than he expected. So what we have to do is he worked 15 hours and he got an extra 50p per hour. So 1 second. So we've got to do 50 times 15. So let's do 15 times 5. Well, actually, let's just do 50 times 15. I'm going to use the lattice method. So here we go. So 15 here and 50 here. So 5 times 5 is 25. 5 times 0 is 0. 5 times 1 is 5. And 0 times 1 is 0. So 0, 5, 7. Okay, so he's going to get 750p more, which is equal to £7.50. So because of the pay increase, he gets £7.50 more, but he's paying £8.90 in tax. £8.90 is more than £7.50, so he's going to get less than he expected. It is less than he expected. There we go. Right, question 12. Complete the list of 6 numbers so that the mode is 6, the median is 13, and the range is 11. Okay, right, so let's do this first, okay? So I'm going to say, if the mode is 9, I'm going to make this 9, and if the range is 11, I'm going to add 11 onto this to get 20 up here. And now what I can do is I can do any 2 numbers that give me a median of 13. Now, it's an even number of numbers, so actually I'm just going to make them both... Oh, they can't be the same thing. 1 second, they can't be the same thing, because if I made them the same thing, that would mean that there were 2 modes. Okay, so I need to make them different numbers. So maybe I'm going to make this one 12. Yeah, that's what I'll do. I make this 12 and this 14, because 13 is in the middle of 12 and 14. There's probably other solutions to this one as well that you could have. Yep, so there are other solutions that you could have for this, but the caveat in the mark scheme is that this has to be 9 and this has to be 20, and that these 2 numbers have to equal 26, okay? So as long as the 2 numbers in the middle add to 26, that's a 9 and that's a 20, this question is fine. Okay, let's look at question 14. So question 14 says, on the grid, draw the graph of y equals 2x minus 6 from minus 2 to 5. Okay, so 2x means it's going up 2 every time, and minus 6 means it crosses the y-axis at minus 6. So I'm going to put my first point here at minus 6, and now what I'm going to do is I'm just going to go up every 2 and put across here, there, 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 And then what I'm going to do is I'm going to use my ruler to join these lines up. And that is that line drawn. Let's have a look at the next question. Okay, so question 15, it says work out 5/8 plus 13/16. So this is adding fractions. So remember, to add fractions, we have to get the same denominator. Now, if I look at these, I can spot that 8 is half of 16. So what I can do is I can, instead of thinking it as 5/8, I can think of 5/8 as being 10/16. So then what we've got 10/16, add 13/16, and that's going to equal 23/16. And it says give your answer as a mixed number. So what I've got to do here is I've got to see how many 16s go into 23. So I'm going to just do 23 take away 16. Okay, so we can't do that. So we've got 13 take away 6 is 7. 1 take away 1 is 1. So this is going to equal 1 whole because 16 goes in the whole time. And then it's going to be 7 over. So here we go. We've got 1 and 7/16. Right, great. Let's look at the next question. So here we go. Question 16 says, here is a triangle on a grid. The triangle is reflected in a vertical line. Two of the vertices of the reflected triangle are 7, 3 and 7, 7. What are the coordinates of the other vertex in the reflected triangle? So let's plot these points first. So 7, 3 is going to be here and 7, 7 will be up here. So there we go. What I can do then is it's been reflected. So let me just our mirror line is going to have been here. So if I finish this reflection off, it will look like this. So the missing coordinates, the final coordinates of the vertex is going to be 10, 3. So 10, 3 is what we're after. And it says here, what is the equation of the line of reflection? Well, along this line of reflection, I'll put it here in the dotted situation. The one characteristic of this line is that everything on this line has an x coordinate of 6. The y coordinates change all the time. They're not committed. They could be anything. But the x coordinate is always 6. So the way that we describe this line is by calling it x equals 6. Let's have a look at question 17. So question 17 says, Ali has £80. He gives 9/10 of his money to Joe. Joe spends 2/3 of his money and gives the rest back to Ali. What fraction of the £80 does Ali now have? Give your answer in its simplest form. Okay, right. So Ali gives 9/10 of his money. So 1 second, we're starting off with 10/10. So 10/10 is equal to £80. So let's then find out what 1/10 is by dividing this by 10. Okay, so we divide that by 10 as well. So 1/10 will be £8. So now what we can do is we can think about what 9/10 would be. So 9/10 of this would be 9 lots of that. So times 9, and then 8 times 9 is £72. So he gives £72 to Joe. Joe spends 2/3 of this. So we're now looking at thirds. So we know that the 3/3 of the money is the whole amount. So the 3/3 is 72. We can then find out 1/3 by doing 72 divided by 3. So I'll just do that over here. 72, 3. So 3 into 7 goes twice with a remainder of once. 3 into 12 goes 4 times. 1/3 is £24. Okay, so actually, that's the amount he's going to give back. If he spends 2/3, he's left with 1/3, and that's what he gives back to Ali. So he gives back to Ali the £24, but Ali still has 1/10 of his money. So this is a horrible question. So Ali is going to have 1/10 of his money, which is £8, plus the third of the money that he gave to Joe, which is £24. So all in all, Ali's going to end up with this. So 8 add 24 makes 32. So he's going to have 32 out of £80. Now, we can simplify this because they're both even numbers. So we can halve them both, which will be 16 over 40. We can halve them again, which will be 8 over 20. We can halve them again, which will be 4 over 10. And we can halve them for a last time, which will be 2 over 5. Okay, so Ali is going to have 2/5 of his money left after this whole adventure. Okay, right. Let's look at the next question. So the next question here is work out the square root of 100 take away 4 times 4 squared plus 5. So let's work out the bracket first. Inside the bracket, we've got 2 squared. So 2 squared is 4. 4 add 5 is 9. Okay, I'll write this down. We've got 100. Take away 4 times 9. 4 times 9 is 36. So we're looking at 100, take away 36. Now 100, take away 36. You might know it or you might not. If you don't, we can work it out using this method here. So 0 take away 6 we can't do. 0, we can't borrow from 0, so we're going to have to turn this into a 10. And then we can borrow from that 10 and turn it into a 9. And so we're kind of looking at this now. We're thinking about that 100 as being broken down into 90 and 10. So what we can do now is we can think about 10 take away 6. Well, 10 take away 6 is 4. 9 take away 3 is 6. So we're now looking for the square root of 64, which we can recognise as a square number. So 64 is 8 squared. So that means the square root of 64 is equal to 8. So there we go. We've got the answer to that question there as being 8. Ooh, right. Let's have a look at question 19. So question 19 says, what does AUB represent in P bracket AUB? Circle your answer. So this means the probability of A or B. I always like to think about this guy in his canoe with an oar. Okay, that's how we kind of remember that one, that symbol there. So that means or, A or B. I know that's not how that or is spelled, but it's something to think about. So this is the probability of A or B. So that means A or B or both. Yep, here we go. A or B or both is going to be what we're talking about. So it's the first one there. Let's look at question 20. Salima is raising money for charity. Her mum says, whatever amount you raise, I will add double the amount. Show this information by drawing a graph on each grid below. Right, so, we've got here on this side the amount added by mum, and we've got here the amount raised by Salima. The mum is going to add double the amount of what Salima makes. So if Salima makes £20, her mum is going to add £40. Okay, right. So first of all, we need to work out the scale. We've got a classic grid here. We've got 5 squares. The 5 squares equals 100. So 1 square will equal 100 divided by 5, which is 20. We've got 20 here. So first double 20 is there. Okay, so that's where the first 40 would be. It's 2 little squares up. Then twice 40 is 80. So that's going to be here. Twice 60 is 120. That will be there. Twice 80 is 160. So that's going to be 8 of these little squares. Twice 100 is 200. So here we go. And then we can join those up into a nice line. So that's the first graph done. What's the second graph done? Total amount raised. Okay, this is interesting. Right, so if Salima has raised 20, we're at 20 here, and then her mum's added 40, so that's going to take us up to 60. If Salima's raised 40 and her mum adds 80, 40 add 80 is 120, so that's going to take us up to here. Okay, if Salima's raised 60, her mum's going to add 120, okay, which is 180 altogether, so we'll get up to here. And then if Salima's raised 80, her mum's going to add 160, which will take us up to 240. If Salima's raised 100, her mum has added 200, which will give us 300. So there we go. So this is the second graph that they want to see. Oh no, what a horrible question. Okay, hopefully you know this. If not, it's one of these things that we're meant to memorise. Write down the value of cos 90. Okay, so the cosine graph looks like this. It starts at 1, goes up and down like this, and there's some key points which it goes through. Okay, so this point here is at 360, and these points here are 1 and minus 1. Okay, and in the middle this is 0. So that's 360 there. This middle bit is 180, and these other two bits here are at 90 and 270. So we can see here at cos 90, we're on this line here. Okay, so we are on the 0 line. So the value of cos 90 is 0. Question 22 says, work out the value of 8 squared times 8 divided by 8 to the power of 9 divided by 8 to the power of 5. Okay, so let's think about these first. Give your answer as a decimal. Right, so let's do the top bit first and see what we've got. So 8 squared times 8 is 8 to the power of 3. Okay, I'm going to rewrite this as a fraction when I do this, because that's what this divide line means. Now, 8 to the power of 9 divided by 8 to the power of 5, well, it means that we've got 8 times itself 9 times, and then we're taking 5 of those times away because we're dividing it by 8 5 times, which undoes the timesing by 8 a certain number of times. So what we end up with here, if we had the 9 eighths, 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to take 5 of them away. 1, 2, 3, 4, 5. So what we're going to be left with, if we're going to be left here with 8 to the power of 4. Now what we've got here is we've got 8 to the power of 3 divided by 8 to the power of 4. Well, actually we can do some more kind of cancelling away here, because this is 8 times itself 3 times divided by 8 times itself 4 times. So what we can kind of do here is we've kind of got 8 times 8 times 8 over 8 times 8 times 8 times 8. And so we can cancel these off in pairs. So cancel those, cancel those, cancel those. And then what we're left with on the top is we're just left with 1. So this equals 1/8. And now what we need to do is we need to turn this into a decimal. And we can do that by doing, well, you might know it, but if you don't know it, we can do it by doing 8s into 1. Okay, so 8s into 1 don't go. Carry the decimal place. I'm looking for 8s into 10. 8s into 10 go once with 2 left over. 8s into 20 go twice with 4 left over. 8s into 40 go 5 times perfectly. So here we go. The answer to this is 0.125. Right, question 23 is write down the line of an equation parallel to y equals 3x plus 1. Right, so the parallel bit is given by the gradient. So as long as you write something that has the same gradient as this line, which is 3x, you're going to be fine. So we could have y equals 3x plus 28. Okay, I picked 28 randomly. You could have had any number. You could have had 23, you could have 1, you could have had -7, you could have had anything, as long as the 3x was still there. Let's have a look at question 24. So here we go. We've got question 24, and at the top it says, a music company releases 10 albums. The scatter graph below shows for each album the number of downloads on the first day and the number of CDs sold on the first day. A line of best fit has been drawn on the scatter graph. Let's have a look. So it has. Lovely. I'm guessing the question is going to be on the next page, but we'll come back to it. The scatter graph shows a positive correlation. Describe the relationship between the number of downloads and the number of CDs sold. Right, so if it's a positive correlation, that means that both things are increasing together. So the more downloads of a song, the more CDs sold, and the more CDs sold, the more downloads there are. Or we could say the number of downloads and CD sales increase together. So I'm sorry, my handwriting's awful, but that's what that means. The number of downloads and CD sales both increase together. So let's have a look at question 24. So 24 says, the company earns £2.50 for each download and £3 for each CD sold. The company releases another album. On the first day, it has 900 downloads. Estimate the total money the company earns from downloads and CDs of their album in that day. So we've got 9,000 times £2.50 for the downloads. So we'll bank that calculation. We'll do that in a moment. But what we've got to do is we've got to use the scatter graph to find out how many CDs we expect to be sold if there's 9,000 downloads. So 9,000 downloads is here, up to here, and then read across. It's there. We can see that we've got 5 squares representing 1,000, which means that 1 square will equal 200. So what we've got here is this is going to be 5,200 CD sales. So we're going to have to do this bit here, 9,000 times 2.5. Then we're going to have to add that to, I forgot what it was, 5,400? Oh, it was 5,400, but I wrote 5,200. 5,400 times 3. Okay, right, so let's do our long multiplication here. So I'm going to use the lattice method for these, and then I'm going to just add them together. So here we go, 1, 2, 3. It's actually going to look like a bit of a waste of time because there's going to be so many zeros, but that's all right. Okay, so 9 times 2 is 18. 0, 0, 0, 0, 0, 0. 9 times 5 is 45. 0, 0, 0, 0, 0, 0. And let's add these together. So that's going to be 0, 0, 0. And this one's 5. This one's 12. Carry the 1. That one's 2. There's decimal points, okay, meet here. And then they go down to here. Okay, so that's where the decimal point would lie. So that first number is 22,500. So 22,500 for that. Now let's do the multiplication for 5,400. I'm just going to do that down here. So 5,400. Then we've just got the 3 this time, so that's nice and easy. So that's 0, 0, 0, 0, 1, 2, because 3 times 4 is 12. And then 1, 5. So we've got 0 there, 0 there, 2 there. That adds up to 6, 1. And so we're going to do 0, 0, 2, 6, 1. So we've got these two numbers to add together, which is going to give 0, 0, 7, 8, 3. So the answer will be £38,700. Okay, and that is, in the mark scheme, they've got a window in which they'd accept. And their window is, they're saying that they'll accept anything between 38,400 and 39,000. So luckily, we are in the window. So let's continue on. Right, question 25. 70% of a number is 350. Work out 120%. So we know that 70% equals 350. So I can see that this is nicely divisible by 7. Okay, so what I'm going to do is I'm going to divide both sides by 7. Divide both of these quantities by 7 to get 10%. Okay, so 350 divided by 7 is 50. So now I want to get up to 120%. So I can do this in stages, or I could just go times 12. I think I'm going to do it in stages. No, I'm just going to go times 12. So times 12 gets us to 120%. Okay, and then we've got to do 50 times 12. Well, I know that 5 times 12 is 60. So this is going to be 600. Okay, so 120% of the number is 600 here. Oh, and it's not, it doesn't say that it's pounds. I was just thinking it was pounds. Okay, there we go. So the answer to that one is 600. Right, question 26. Question 26 says, here is a graph of 0.5x squared minus 6x plus 12. Use your graph to estimate the solutions of when this graph equals 0. Okay, so this graph equals 0. If you'll notice on here, it's the thing about this is that's y equals this, and then this equals 0. And so what we're really looking for is we're looking for when y equals 0. So that line, that y equals 0, is given by this line here. Because if you see here, on all these different points, we've got y equaling something. Say, for example, this line would be y equals 10. This line here would be y equals 5. But we want y equals 0. So we're looking for the points where the graph crosses the axes at y equals 0, which is here and here. Now, I can see that they've just got one square for a whole number. This seems to lie in between, right in the middle. So I think that looks like x equals 2.5 as one of the solutions. Or this one, it looks like it's halfway in that square as well. So I'm going to call that x is 9.5. So here we go. These are my two offerings for this. Yeah, they both fall within the margin of error. The mark scheme has said they wanted this 2.5 to be between 2.25 and 2.75, and they wanted this 9.5 to be in between 9.25 and 9.75. Right, let's have a look at question 27. So question 27 here says, shape A is a circle with a radius of root 17 over 2. Shape B is a sector of a circle with radius 5 centimeters. Which shape has the greater area, A or B? Right, okay, so the area of a circle is pi r squared. So let's have a look at what this means for shape A. So this is going to be pi times root 17 over 2 all squared. Now, what this is wanting us to know is that root 17 squared is 17. So if you yeah, if you square any square root, you get back to the square number. So, for example, root 4 would be 2, and then 2 times 2 equals 4. So root 17 squared is 17. So this becomes 17 over 4, because 2 squared is 4. And then we'll just put 17 over 4 pi, because that just means times pi. Now, this other one, we've got all the numbers here. There's nothing funny about it, but we've only got 60 degrees out of the circle. So that's 60 degrees out of the whole circle, which is 360. And then we're going to times that by the area of the circle, which would be pi times 5 squared. So let's sort out these numbers a bit so that we can compare them. We're basically looking for which coefficient is larger. Is this larger, or do these bits make something that's larger than 17 over 4? Well, 60 over 36 we can simplify instantly to 6 over 36. And then 6 over 36 is like 3 over 18. Then you can divide both of these by 3, which is like 1 over 6. So, and then 5 squared is 25. So 1 over 6 times 25 equals 25 over 6. Now, this is tricky, okay? It's difficult to say what's going on here. But what we can do, we've got the sector has the area 25 over 6 pi, and the whole circle has the area 17 over 4 pi. So we need to be able to compare these numbers. So we're going to need to get them over a common denominator in order to do that. So what I'm going to do is, I think that will happen relatively quickly actually if we just double these things. So let's go with 17 over 4 first. 17 over 4 could equal 34 over 8. And then that could equal, actually I know how this is going to work. We need to get them over 12. Okay, so if we add these, not that that's the right thing to do, but what we're doing is basically we're thinking about this as 17 over 4 equals, if we're timesing this by 3, that goes to 12, and then we need to think of 17 times 3. Well, 17 times 2 is 34. 17 times 3 would be another 17 on the 34, which would take us to 41, 51. Okay, so 17 over 4 is 51 over 12. 25 over 6 equals 50 over 12. Now these numbers are very easy to compare. 50 over 12 and 51 over 12. We can see that 51 over 12 is larger. So therefore what we're going to say is shape A is larger. Okay, does it want to know by how much? No, it just wants to know which one's larger. Shape A. So here we go, because shape A has an area of 51 twelfths pi, and shape B 51 over 12 pi centimeters squared, and this is 50 over 12 pi centimeters squared. Very close actually. Right, let's have a look at there's more on this. Let's have a look at these questions here. So this question here is factorise x squared plus 2x minus 24. So this is a double bracket one because we've got the 3 parts. So we want x here and x here, and then 2 numbers that multiply together to make 24, and then that we can combine with positives and negatives so that we've got a difference of 2. Okay, so I know that that's going to be 4 times 6, okay, and I need it to be positive 2, so I need it to be positive 6 and negative 4, because when we do 6 take away 4, that gives us 2. So here we go, we've got our answer there. I'll rewrite it on the number line here. Okay, right, so here we go. Next question, 29a, we've got write 2 times 10 to the power of 3 as an ordinary number. So that's going to be 2 times 1000, which will equal 2000. Right, part B is simplify 2 times 10 to the power of 3 to 5 times 10 to the minus 1. Give your answer in the form n to the 1. So that's going to be 2000 from above. And then 5 times 10 to the 1 is 5 with 1 0 in front of it, including its decimal place. So here we go. We've got this like this. And we want this side to be 1, which is lucky because 0.5 is pretty close to 1. So all we have to do is times the ratio throughout by 2. So that's going to give us 1 there and 4000 here. So the answer will be 4000 to 1. And that is the end of the questions. So very well done, and thank you very much for sticking with me. If you need any help on any of these topics, I've got loads of lessons on these different things, on fraction skills and stuff like that, all on the Crack Maths website, and I will try and put some links into the description when I get some time. Thank you very much for joining me, and see you in another video. Bye.